so first four here, trying to just name what kind of solid is going to be created from that net. And so the first one, you have two hexagons, one on top, one on bottom, and then a bunch of rectangles in between. And so that's going to be a prism. And you have two congruent bases that would be parallel to each other, and the bases are hexagons, so it's a hexagonal prism. All right. Number two looks kind of similar to number one, except for you got a circle on top and bottom. And so having two congruent bases that would be parallel that are circles makes that a cylinder. Number three, you got one hexagon with a triangle going out from every side of the hexagon. So if you brought all those triangles together, you're going to make a pyramid. And since the base is a hexagon, it's a hexagonal pyramid or hexagon-based pyramid, depending on what text you look at to tell you what to say. All right, number four, you got a bunch of rectangles. So we put those rectangles together to make what looks like a box, or what would be a rectangular prism. Alright, so next group, find the surface area of each figure and round your answers to the nearest hundredth if necessary. Alright, so I've already went ahead and put the base formula for surface areas of each one of these there. Alright, so for a cone, surface area is pi r squared plus pi r times L, L being the slant height. So pi times the radius squared plus pi times the radius times the slant height. So surface area is going to be pi times r squared, which is 10 squared, which is going to be pi times 10 times the slant height, which it gives us as 22.4. It's going to be 100 pi plus 224 pi. So 324 pi. If we multiply that out, it's going to give us a surface area of 1017.88, taking it to the hundredths place, miles squared. All right, so then next one, number 6, is a prism, and it's a rectangular prism, or more specifically, the bases are going to be squares. So 2 times area of the base plus the perimeter times the height. Area of the base, since the bases are squares, is just going to be the side squared, or 9 squared, which is 81. Perimeter for a square is 4 times the length of a side. That would be 4 times 9, which is 36. And our height here is the 2 centimeters between the two squares. So surface area is going to be 2 times 81 plus the perimeter of 36 times a height of 2. It'll be 162 plus 72. So that's going to be 234 and unit centimeters squared. Alright, number 7. Surface area is 2 times area of the base plus the perimeter times the height, because it's a prism again. This time it's a hexagonal prism. So the bases are hexagons. So the area of the base of a hexagon, we use the 1/2 the apothem times the perimeter formula. And thankfully they gave us the apothem. That's what the 7.8 miles is, that segment going from the center to the side. So A is 7.8. Our perimeter, since it's a regular hexagon, is going to be 6 times the length of the sides, which is 9. So we got 54 there. So figure area of the base, we're looking at 1/2 of 7.8 times 54. To give us 210.6. That's just area of the base. So we have to use that along with the perimeter and the height to find the surface area. So 2 times area of the base, or 2 times 210.6, plus the perimeter, which we already figured out is 54, times the height, which the distance between the hexagons is 4 miles. So surface area is going to be 421.2 plus 216, which is ultimately going to be 637.2 miles squared. Alright, number 8 is a pyramid, and more specifically a triangular pyramid or triangle-based pyramid. So the base is a triangle. So for area of the base, we're using 1/2 base times height for area of a triangle. And so our area of the base is going to be 1/2. And the base of the triangle is 3 yards. The height of the triangle is the 2.6. So 1/2 of 3 times 2.6 will be 3.9. Alright, the perimeter, all 3 sides are 3 yards, so 3 times 3 will equal 9. And the slant height's given to us as 4.1. So plug all that in to the surface area formula. It's going to be area of the base 3.9 plus 1/2 of the perimeter, which is 9, times the slant height, which is 4.1. And if we multiply that all out, it's going to give us a surface area of 22.35 yards squared. Alright, so a few more still finding surface area of. Number 9 is a pyramid, but this time it's a square-based pyramid. So area of the base is a side squared, or 12 squared, which is 144. The perimeter for a square is just 4 times the length of a side. Just 4 times 12, 48. And the slant height L is 10.8. So for surface area, we have 144 plus 1/2 of 48 times the slant height of 10.8. Multiply and combine all of that. And we're going to get 403.2 miles squared. All right, number 10, we have a cylinder. Follows the formula 2 pi r squared plus 2 pi rh. And so makes it a little easier since we're just plugging in the radius. So 2 pi times the radius, which is 2 squared, plus 2 pi times 2 times the height, which is the distance between the circles, which is 3. So 2 pi times 4 plus 2 times 2 is 4 times 3 is 12 pi. So 8 pi plus 12 pi is 20 pi. We've got to get it in a decimal form. So 20 times pi will give us 62.83 centimeters squared. So then we've got a sphere. Surface area equals 4 pi r squared. So our radius is going to be half of 4 because they give us the whole diameter, which so that's 2. The surface area is 4 times pi times 2 squared. 4 pi times 4. And 4 times 4 is 16 pi. And 16 times pi give us a surface area of 50.27 meters squared. All right, so then the next group is all volumes. So first one, 12, is volume of a rectangular prism. So the bases are triangles that are 8 by 1. So area of the base, since it's a rectangle, is length times width. And so that's going to be 8 times 1, which is going to be 8. And the height is 6. So volume is 8 times 6, or 48 feet cubed. And so then 13, a little bit more complicated, maybe just because we don't remember off the top of our heads usually the formula for area of a trapezoid, since it's a trapezoidal prism. Bases are trapezoids. So formula for area of the base is 1/2 the height times base 1 plus base 2. So that all deals with within the trapezoid. So that's going to be 1/2. The height of the trapezoid is 4.6. The base of the the two bases of the trapezoid are 8 inches and 4 inches. So 8 plus 4. So 1/2 of 4.6 times 12 And if we multiply that out, so that's going to be area of the base is 27.6 inches squared, and for the volume, it's area of the base times height, so 27.6 times 10. So our volume is going to be 276 inches cubed. Number 4 here is a pyramid. Follows the formula 1/3 area of the base times the height. They give us a triangular pyramid, which we can see the triangle is a right triangle. So when we use area of the base as 1/2 base times height, we can use 8 and 6 for our bases and height, base and height. So it's going to be 1/2 of 8 times 6, which is half of 48, or 24. So for volume, we're going to have 1/3 area of the base, 24, times the height, which is 8. And 1/3 of 24 is 8. 8 times 8 is going to give us 64 feet cubed for volume. 15, another pyramid. This time it's a square base. So for area of the base, it's the side squared, or 2 squared, which is going to be 4. So volume equals 1/3 of the area of the base, which is 4, times the height, which is 3. Which 1/3 of 3 is just 1, so it's 1 times 4, or just 4 meters cubed. Mm-hmm. 16, we have a cylinder. Follows the formula, volume equals pi r squared h. So our volume is going to be pi times the radius, which is 7 squared, times the height, which is 4. Pi times 49 times 4. So volume is 196 pi. Multiply that out. So our volume is going to be 615.75 kilometers cubed. 17, we have a cone. Follows the formula, volume equals 1/3 pi r squared h. So volume is going to be 1/3 pi. The radius is 12. It's 12 squared times the height, which is 24. So 1/3 of pi times 144 times 24. Multiply all that out. So it's 1152 pi times pi is going to give us 3619.11 yards cubed. And 18, looking at volume of a sphere. And so 4/3 pi r cubed. So the radius is going to be 22 divided by 2, since they gave us the diameter, 11. So we have 4/3 pi times 11 cubed. So the volume equals 4/3 pi times 1331. And multiply that out. Can give us a volume of 5575.28 miles cubed. All right, so now on to the next section, determining if the two figures are similar. So we're going to compare the corresponding parts as ratios. If the ratios are the same, then they're similar. If the ratios are not the same, they're not similar. So 19, make a ratio out of the corresponding parts. We have 27 and 36 for the base lengths, for the side lengths of the base. And the slant heights for both of them are 32. 27 over 36, they both divide by 9, which will give us 3/4. And 32 over 32 is just 1 over 1. So since those are not equal, and not similar, all right, so then the next one, a couple of cylinders. One thing we have to recognize is they give us the radius on the left one, but they give us the diameter on the right one, so divide that by 2. Give us 50 inches for the radius. So compare those. 40 over 50 for the radii should be equal to 20 over 25 for the heights. 40 and 50 divide by 10, which will give us 4/5. 20 and 25 both divide by 5, which will give us 4/5. So those actually are equal to each other. And so the scale factor is going to be 4 to 5. Right, those are similar, or yes, they are. All right. So next up, each pair of figures is similar. Use the information given to find the scale factor of the figure on the left to the figure on the right. All right, so first off, if we left to the right, looking at 2560 or 3645. And both of those I can tell divide by 5. So 2560 divided by 5 is going to give us 512. And 3645 divided by 5 will give us 729. All right, so that's the reduced ratio there. But this is the ratio of the volumes. So remember, to go from volumes to the scale factor, so write it as a ratio 512 to 729. To go from there to the scale factor, we have to take the cubed root of the ratio of the volumes. So cubed root of 512 is going to be 8. Cubed root of 729 is going to be 9. So the scale factor is going to be 8 to 9. All right, so the next one, we got 82, 32, 24. Which 82, 32 actually divides evenly by 24 to give us 343 over 1. And so that's a ratio of the volumes, 343 to 1. So just like the last one, we have to take the cubed root of both of those. And so the cubed root of 343 will be 7. Cubed root of 1 is just 1. So 7 to 1. At 23, we got 44 and 396. 44 over 396. Write it right. 44 over 396. And both of those, I believe, divide by 11. So that reduced to be 4/36. So our ratio is 4 to 36. And these are, this time, our surface areas. So we know that the ratio of the surface areas is the square of the scale factor, or to get the scale factor we have to take the square root of those to give us 2 to 6. Or actually I should have reduced that down. That's 4 over 6 would have gone down to 1 over 9. So those actually divide to 1 to 3 since they both divide by 2. So 1 to 3 would be the final scale factor there. Alright, so then 24, we're going to have 80 to 20. Reduce that down, that's going to give us 4 to 1. Or write it as a ratio. And that's the ratio of the surface areas. So to go to the scale factor, we take the square root. It's going to give us 2 to 1. So then 25 and 26 says each pair of figures is similar. Find the scale factor of the figure on the left to the figure on the right. Then find the ratio of surface area and ratio of volume. So this is kind of the reverse of what we just did. First we're going to find the scale factor. So first off, 80 is the diameter, and they gave us the radius on the other one, so divide that by 2 to give us 40 miles for the radius. So we're looking at 40 to over 30. Both of those divide by 10 to give us 4/3. So scale factor is going to be 4 to 3. And then the ratio of area we square those, so 4 squared to 3 squared, which is going to give us 16 to 9. And then for ratio of volume, we cubed that, so 4 cubed to 3 cubed, and which is going to end up being 4 cubed 64, 3 cubed is 27. So 4 to 3, 16 to 9, and 64 to 27. All right, so then next one there, they gave us a couple of measures we can use. I'm going to use the smaller numbers just because that's usually easier to deal with. So left one to the right is 72 over 45. Both of those numbers divide by 9, which is going to give us 8 to 5. So the scale factor is 8 to 9. Ratio of area, we're going to square that, so 8 squared to 9 squared. So it'll be 64 to 81. Ratio of volume, we cube it, so 8 to 9, and we cube those, 8 cubed to 9 cubed. It's going to give us 512 to 729. So 8 to 9, 64 to 81, and 512 to 729. And the last section, the scale factor between two similar figures is given. Surface area and volume of the smaller figure are given. Find the surface area and volume of the larger figure. So for the first one, the scale factor is 5 to 8. The ratio of area, we would square that. 5 squared to 8 squared, or 25 to 64. Ratio, so then ratio of volume, it's going to cube those, so 5 cubed to 8 cubed. So that'll be 125 to 512. So they give us a surface area of 225. So to find the surface area of the new one, we take the surface area of the smaller one with the surface area, or the area ratio, which is 25 to 64. That's going to be equal to the surface area 225 that they gave us over the surface area of the larger figure. Cross multiply 25 times the surface area of the large figure. It's going to equal 64 times 20 times 225. 14,400. And divide by 25. So surface area of the larger figure is going to be 576 feet squared. And for volume, we're going to take the volume of the bit, or the volume ratio, 125 over 512. Can't write. 125 over 512 equal to 2375 over volume of the large one. Cross multiply 125 times the volume of the large one is going to equal a big number, 512 times 2375, 121,600. Divide by the 125. So the volume of the large one is 9728, and that'll be feet cubed. Alright, so then for 28, same process. Take the scale factor to find the ratio of the area. I'm going to square it, so 2 squared to 7 squared, which will be 4 to 49. Ratio of the volume is going to equal 2 cubed to 7 cubed. So that'll be 8 to 343. So for the surface area of the new one, I'm going to take the ratio of area, 4 over 49, equal to 20 over the surface area of the large one. Cross multiply. 4 times the surface area of the large one is going to equal 49 times 20, or 980. Divided by 4. So the surface area of the large one is 245 inches squared. And then for the volume, ratio of the volume, 8 over 343. It's going to equal the volume of the small one, 136, over volume of the large one. Cross multiply. 8 times the volume of the large one, 136 times 343, which is 46, 648, divided by 8. Be 5,831 inches cubed. And that completes the review.